Hey guys, today we're looking at simplifying algebraic fractions, and I know um, from past experience, fractions isn't always something that people are fond of, but it's really important that with something like this, there's three elements that you need to be really competent with, or at least highly familiar. One, fractions. Two, your timetables, okay, when it comes to factors and multiples, that is really important. And three, algebra, okay. So I'm hoping at this stage you'd be continually revising on all three of those elements because it is very important. Okay, so I'm going to do several examples because this is a fairly big part of the chapter. And hopefully, you take your time. It's really important that you don't rush this. And until you have a higher success rate of getting things right and not making those little errors along the way, then you can potentially speed things up. So here we go. As you know, with when you multiply fractions, you can cross simplify. You can simplify diagonally. You can simplify vertically, but you can't simplify horizontally. Okay, you can't do that. So here we have two fractions multiplied by each other, and what we do have is we have x plus 3 and x plus 3 in common. Okay, remember we can simplify diagonally, and therefore these are common factors. They can cancel out, leaving you with 4 on the top and 5 at the bottom. Okay, if we moved on to something a little bit more substantial, and we had, say, z minus 3, z minus 4, z minus 5, z plus 1. So that's a z, not a 2. And then we got z plus 1, z minus 1, and then we have z plus 3 and z minus 3. We're going to do exactly the same thing. We can look at the factors that are diagonal. Notice that we have a 2 plus 1 and a, oh sorry, a z, already made that mistake. A z plus 1 and a z plus 1, they cancel out, okay? And we can look on the other side. We have a z minus 3 and a z minus 3. They can cancel out. And all we're left with is z minus 4, and then z minus 1 on the top, and then z minus 5, and z plus 3 at the bottom. And that's what we're left with. None of these bracketed factors are in common with the top and the bottom, so you do not do anything else with it. There is no need to expand, okay? We're not, the whole idea of simplifying and we're making it smaller. The moment that you start expanding the brackets, you're then going the opposite direction. You're not doing, you're not going in the right direction that it's really seeking and asking for. Want you to understand that these two sets of brackets, or what we have there, you would say that they are your factorized form of your quadratic expressions, okay? So all of these here that we have on these four parts of the fraction, so the top here, the bottom here, top here, and the bottom here, they are factorized quadratic expressions, and we need to factorize it before we can actually get to canceling out and simplifying the fractions. Okay, so we'll move on to some other examples just as we build the case here, so you understand what's happening. Okay, so let's actually first off look at some division, because division is only one little extra step different. No, actually, it's not really different. It's one extra step in addition to multiplying your fractions. So let's go 1 over x minus 3 divided by 3 over x minus 3. And we know, or you should know, that when you divide fractions, you change it to a times and you get the reciprocal of the second. The reciprocal means you flip the second fraction around. That is the only extra step that you do beforehand, and everything else afterwards is exactly like you would do with multiplying fractions. So here we have a common set of factors, x minus 3 and x minus 3, and all you're left with is just 1 over 3. So same thing with this set. So z plus 2, z minus 3 over z minus 4 divided by z minus 3 over z minus 4. Okay, so change to a times. We flip the second fraction around and we keep everything on the left the same. Okay, so now what we have is we have common brackets here that we can cancel out, and diagonally we can see that the z minus 3 can cancel out with that z minus 3. All we're left with is z plus 2 as your answer. Okay, so the moment that you see these common brackets, just get rid of them, making sure that it's all in order. Okay, so we're going to move on to some other examples where we need to factorize first before we simplify. And we'll build on the different forms of, or different levels of factorizing, just to recap of what we've done earlier in the chapter to get everything in motion. Okay, first one, we have 3x plus 9 over 15. Okay, next one, I'm going to have 5 over 10x plus 20. Next one, we'll have 10x plus 15 over 6x plus 9. And lastly, we'll have x squared plus 4x over x squared minus 5x. This is not the end of it. This is just the start. Okay, so what we can see at the top, we can actually simplify, or sorry, factorize a common factor of 3 and have x plus 3 inside the brackets, because both the 3x and the 9 are divisible by 3. We can then leave the 15 below. Remember that this is 3 times x plus 3, and we got 15 at the bottom. What we can do is the 3 and the 15 can cancel down to a 1 and a 5. Obviously, we don't need the 1, so x plus 3 remains on the top, 5 stays at the bottom. That's all that's required. Okay. Because the 15 is, simply as 3 times 5, and the 3's can cancel out. Okay, next one. So we can't factorize the top, but we can factorize the bottom. Both 10x and 20 have a highest common factor of 10. And so then x plus 2 is going to be at the bottom, and 5 is on the top. We can see that 5 and 10 have a common factor of 5. Okay, highest common factor of 5. So we can then make this 1 on the top and then 2 at the bottom. Okay. Next one. We can factorize both the top and the bottom. So remember the theme or the pattern here, the routine is to factorize first and then simplify afterwards. Okay, please don't simplify before you've factorized. It's really important that you take it down into its factorized form before you start taking things out. Trust me, it's going to be a lot easier and it will save you from making mistakes. So highest common factor between 10x and 15 is 5. There aren't any common letters, so we'll have 2x plus 3 as our factorized form on the top. And then what we'll have at the bottom is the highest common factor is a 3, and we'll have 2x again plus 3 as its common factor at the bottom. So we go 3 times 2x is 6x, and 3 times 3 is 9. So if you ever want to check your factorizing, just expand it. So notice with the previous two, our common factors were the coefficient of the brackets, the numbers in the front of the brackets. But now the common factor is actually the brackets itself. So we can cancel out the 2x plus 3, because that's what is in common with the top and the bottom, leaving you with 5 over 3. Okay, so last one here for this page here, we've got x squared plus 4x and x squared minus 5x. So the factorizing becomes a little bit more substantial. We'll get into monic and non-monic expressions later on. And so we're just going to do this first. So factorizing the top is x, and then we're left with x plus 4 inside the brackets. If you want to check, x times x is x squared. X times 4 is 4x. So we're going to do the same thing with the bottom. X is the common factor, or the highest common factor, and x minus 5 is going to be at the bottom. Okay, so the brackets aren't the same, so we're not going to change anything there, but we can cancel out the coefficients or factor of x from the numerator and the denominator. So the answer is just x plus 4 and then x minus 5 at the bottom. Okay, let's keep on moving on to more substantial ones, and we'll have, say, x squared plus 3x minus 4 divided by x minus 1, and then we'll have, say, x squared minus 7x minus 8 over x squared plus 3x plus 2, and then even further from that we'll have x squared minus 6x plus 5 over 2x squared minus 16x plus 30. All right, so again, with all of these, you just want to take your time. You don't want to rush it. You don't want to skip steps. Yep. Okay, so looking at this top expression on the left, it is a monic expression. Okay, monic expression meaning that there's a coefficient of 1 of x squared. So we need factors of minus 4 that add up to 3 and positive 3. Okay, so we will have a positive 4 times a negative 1 is equal to minus 4, and a 4 minus 1 is equal to 3. So it fits both of those descriptions. So our quick reference is then going to be x minus 4, x plus 3 is going to be your factorized form on the top. And then we have, we're going to have x plus 4 as our brackets, and then x minus 1 as our second set of brackets, and then x minus 1 at the bottom. Okay, because the two numbers that we chose is 4 and minus 1. We can see that x minus 1 and x minus 1 are two brackets in common. Our final answer is just x plus 4. Okay, so now we look at the middle equation, and we do have, again, two monic expressions. We have minus 8. So the factors of minus 8 that add up to minus 7 is minus 8. And it's really important that you get your negatives and your positive values correctly, okay? If you end up getting positive 8 and negative 1, please check, because positive 8 minus 1 doesn't give you minus 7, so you need to reverse the polarity. So the two numbers that we need to deal with is that. So we've got x minus 8 as one set of brackets, x plus 1 as your second set. When we're looking at the bottom expression, it again is a monic, and your factors of 2, well, it's a prime number, so you only have 2 and 1 to deal with. So 2 times 1 is 2, 2 plus 1 is 3. So we have x plus 2, and then x plus 1. Do we have common brackets? Yes, we do. X plus 1 and x plus 1 can cancel out. The other two, they can't, so don't force it. X minus 8 is on the top. X plus 2 is on the bottom. Okay. The one over here on the right, we have another monic expression on the top here. And so factors of 5 that add up to -6. Well, we can say that -5 times -1 is 5. And then -5 plus -1 is -6. So they're gonna be our two numbers. X minus 5, and then x minus 1 is going to be on the top. Okay, now with the bottom, we need to factorize this a little bit further before we do anything else. We can see that 2, 16, and 30, they're all even numbers. So what we can do is we can actually take out a common factor of 2, and then we'll have x squared minus 8x plus 15. So we've divided this by 2, we've divided this by 2, we divided that by 2, having that at the front. What we're left with is on the inside, we do have a monic expression. And factors of 15 that add up to -8 is going to be -3 and -5. So -3 times -5 is +15. -3 plus -5 is -8. So what we have at the bottom here, we'll end up having x minus 3 and then x minus 5 at the bottom. So this is our factorized form for the denominator. This is the factorized form for our numerator. What we have in common, we have common set of brackets of x minus 5 and x minus 5. There is nothing else that's in common that we can take out, so we'll leave everything as is. So x minus 1 on the top, and then 2 outside of x minus 3 at the bottom. Okay. I'm going to finish off with one more example, and I'll do that over here. And it's really important that, again, take your time, assess what's going on, and then work from there. So 2x plus 4 over 3 times 3x minus 3 over x plus 2. Okay, so I will actually do one more example after this, so hang around. So what we have here, we've got two fractions, and we're going to build from here and factorize each of these quadrants and then simplify. So we've got a common factor of 2 on the top left, so we're going to take out 2. X plus 2 is going to be inside, 3 at the bottom. The highest common factor on the right, top right, is 3. X minus 1 is going to be at the top. X plus 2 is going to be at the bottom. And whether you want to put brackets around that or not, that's really up to you. I just find it helpful for a visual thing. X plus 2 and x plus 2 can cancel out. The 3 and the 3 can also cancel out, leaving with nothing at the bottom, okay? And so all you have on the top is 2 outside of x minus 1. Okay, now we're going to move on to something that's a little bit bigger, and hopefully you are okay with it. Here we go. So we got x squared plus x minus 6 over, let's say, x squared plus 5x minus 14 multiplied by x squared plus 9x plus 14 divided by x squared minus x minus 12. Okay, so we've got these 4 quadratic expressions. We need to factorize each of those 4 before we simplify things. So the top left is going to be simplified down to x plus 3 and x minus 2, because 3 times minus 2 is minus 6, and 3 minus 2 is 1. Okay. Bottom one, factors of 14, minus 14, that add up to 5. I'm looking at x plus 7 and x minus 2. Minus 2 times 7 is minus 14. 7 minus 2 is 5. So always check that to make sure. Factors of 14 that add up to 9, that's going to be x plus 7 and x plus 2. 7 times 2 is 14, 7 plus 2 is 9. And then factors of minus 12 that add up to minus 1 is minus 4 and positive 3. So minus 4 times 3 is minus 12. Minus 4 plus 3 is minus 1. So I've now factorized all 4 parts, and all I need to do from here is cancel out the common brackets. So I can see there's an x plus 3 and x plus 3. I see an x plus 2, x minus 2 and x minus 2. I also see an x plus 7 and an x plus 7. They can all cancel out. All that's left is an x plus 2 on the top and an x minus 4 at the bottom. Okay, so hopefully that helps you guys. If you have any questions, let me know. Otherwise, see you in the next one.